Hey everyone, and welcome. If you're revising for your OCR GCSE in computer science, then you have come to exactly the right place. Today, we're getting laser focused on section 2.5. That's all about programming languages and IDEs. So think about it. You spend all this time crafting your code in something like Python or maybe Java. It looks perfect. It makes sense to you. But did you ever just stop and think, what's really going on under the hood? How does this computer, this machine that only gets ones and zeros, possibly understand your brilliant program? Well, that's the big question we're going to answer today. We are going to break down everything that OCR needs you to know, and we're going to turn all those complicated ideas into simple, memorable points that are actually going to stick with you in the exam. All right, you ready? Let's dive in. Okay, first things first. We have to get our heads around the fact that not all programming languages are the same. They kind of exist on this spectrum, from languages that are super easy for us humans to read and write, all the way down to the languages that a computer processor understands directly. And this slide really breaks it down for us. So on one side, you've got your high-level languages. Think Python. They use English-like words, and they're what we call machine-independent, which basically just means you can write the code once, and it'll run on a Windows machine, a Mac, whatever, without you having to change it. Then, on the other side, you've got low-level languages. These are way, way closer to the raw ones and zeros the computer actually thinks in. Now, this makes them incredibly fast, but it also means they're usually tied to just one type of computer. And honestly, they are much, much harder for a person to read and write. So here's the thing. The really crucial point is this. We love writing in these easy, high-level languages, right? But the computer, it only understands those difficult, low-level instructions. So how on earth do we bridge that gap? How do we get our human-friendly code translated into something the machine can actually use? Well, the answer lies in a special kind of program called a translator. And for your exam, you need to know about two specific types of translators: compilers and interpreters. So, a translator's job. I mean, it sounds simple, but it is absolutely essential. It takes the source code, that's the stuff you wrote, and it converts it into machine code, the raw binary instructions that the CPU can actually do something with. Seriously, without a translator, your amazing program is just a useless text file. Okay, this table here is so important for your exam because it lays out the totally different ways compilers and interpreters work. Let's walk through it. A compiler, that's the one on the left, it's kind of like a professional book translator. It reads your entire program, the whole thing, all in one go. It checks it from top to bottom, and then at the very end, it gives you this big list of all the mistakes it found. If everything's okay, it spits out a brand new standalone file, an executable. An interpreter, though, is completely different. It's more like a live interpreter at a conference. It works line by line by line. It translates one line, runs it, translates the next line, runs it. And the second it hits an error, bam, it just stops right then. And this leads to this classic trade-off, and you absolutely need to know this. Because the compiler does all of that translation work up front, the final program it creates runs incredibly fast. But finding and fixing bugs can be a pain, because every single time you change something, you have to recompile the entire program all over again. Interpreters are the total opposite. They run slower because they're translating on the fly, right? But debugging is so much quicker because the program stops at the exact line where the problem is. All right, so we've talked about languages and the translators that convert them, but where does all this magic actually happen? Where does a programmer sit down and actually write, test, and translate their code? Well, that brings us to our third key topic, the Integrated Development Environment, or IDE for short. Yeah, you can think of an IDE as basically the command center for any programmer. It's this single piece of software that brings together all the essential tools you could possibly need to write, test, and translate your code, all in one place. I mean, I love this analogy. Just think, if you were a carpenter, you wouldn't want your saw in the garage, your hammer in the kitchen, and your nails out in the shed, right? No way. You'd want everything together in your workshop, right? Well, an IDE, that's the programmer's workshop. So what's inside this workshop? Well, for your exam, you need to know about these 4 key tools. Let's take a quick look. First up, you've got the editor. This is just where you type your code, but it's smart. It does things like color code your text to make it easier to read. Next, you have error diagnostics. Oh, this is a total lifesaver. It spots mistakes as you type, usually underlining them in bright red so you can fix them straight away. Number 3, you have your built-in translators. The IDE has a compiler or an interpreter right there, ready to go with just a single click of a button. And finally, number 4 is the runtime environment. This is like a safe sandbox where you can actually run your program, see what it does, and hunt down those really tricky logical mistakes. Phew! Okay, we have covered a ton of ground, so let's pull all of this together with a super focused checklist of exactly what you need to remember for the exam.
Okay, listen up because this is really important. First, a top tip straight from the official spec, you do not need to revise assemblers, so don't waste your time. Focus your energy here instead. You absolutely do need to know the differences between high and low-level languages. You must be able to compare the pros and cons, the benefits and drawbacks of compilers versus interpreters. And finally, you need to be able to explain the purpose of those 4 main IDE tools we just went through. That's it. If you can master those 3 points, you are golden for this section.
Look, I know it can feel like a lot to remember, but when you break it down like this, you can see it's all totally manageable. Just focus on these core ideas, practice explaining them out loud, and you'll be more than prepared. You've absolutely got this. So I'll leave you with a final thought to kind of connect all this back to your own coding experience. Of those 4 IDE tools we talked about, the editor, the error diagnostics, the translator, and the runtime environment, which one do you think is your biggest lifesaver when you're programming? Have a think about it because figuring out why will really cement these ideas in your head. Thanks so much for joining me.